So again, I want to factor this trinomial, but notice how again it's not a perfect square trinomial because there's really nothing squared that gives me this 10y squared. So this falls into the category again of a general trinomial. Now what makes this one difficult is the coefficient of the quadratic term is not 1. So we have this form ax squared plus bx plus c. Again, a does not equal 1. So it now comes into play in our problem. So again, since there is not a GCF, so miswrote that there. I'm going to try that again. So since there is not a GCF, what we did is we use what's called Foursquare. So using Foursquare is my grouping strategy. So again, make sure you give yourself enough room on the top and on the bottom and enough room to write inside of it. So I've done this enough that I kind of get pretty good at just drawing the box. So once we draw Foursquare, the strategy is the quadratic term will go on the top left. That's the 10y squared. So the 10y squared will go here. The constant goes in the bottom right. That's the 1. Now the catch is we got to create two linear terms. The strategy for that is we multiply the quadratic term coefficient to the constant. In other words, this a times c. So this a times this c would be 10 times 1. So 10 times 1, what we do is we can make a table. So we have our 10. 10 times 1 is 10. But now the catch is we have to use this number to create the coefficients of the linear term. So the factor of this number must add equal the linear term coefficients. So what we have to be doing is we have to be adding to get a 7. So if we look at this problem, we're kind of seeing, well, 1 times 10 is 10. 2 times 5 is 10. Notice how that 2 times 5 is 10, but also 2 plus 5 is 7. So we're going to use these to be the coefficients of my linear terms. So y there. So we're going to have now this 2y and this 5y. So the 7y becomes two terms. We break it apart. Now from here, I'm just going to model the rest of this. So we want to do the GCF of the top row. So what does a 10y squared and a 2y have in common? Well, it looks like as far as the numbers go, the 2 works, and they both have a y in common. So what I'm going to do is divide out or pull out a 2y. A lot of times we call factor out. If I look at the bottom, I'm really not seeing a common factor, 5y1, so the smallest factor you could have is just simply a 1. So when there's not a common factor, it's just simply a 1. So we would have that going on there. Now, if we play this out, what times 2y gives me 10y squared? It looks like I need a 5y. 5y times 2y does give me 10y squared. What times 2y gives me 2y? Well, I would just need a 1, because remember, when you multiply by 1, it doesn't change anything. 1 times 2y does give me 2y. Now, if I check this bottom row, does 5y times 1 give me 5y? Yeah. Does 1 times 1 give me 1? So notice how that all checks out. So notice how the outside fits the inside. So we've kind of already double checked ourselves. So remember, the outer edges are our two binomial factors. So the 2y plus 1 becomes one factor, and the 5y plus 1 becomes the other factor. And we've completed it. It's now a factored polynomial.